Good morning to all. Now we see about the basics of fuzzy sets. That is, why do we need about fuzzy sets, and what is the definition of a fuzzy set? Actually, fuzzy set is a very useful tool to describe situations in which the data are vague or imprecise. Actually, fuzzy sets handle these situations by attributing a degree to the certain object belonging to that set. So, but basically, fuzzy set theory is an extension of our classical crisp set. It is a natural way to deal with the imprecision. Many real world situations relies on significance rather than precision. Fuzzy logic is the best way to deal with them. Fuzzy set is thus the extension of a classical crisp set. For example, if we wish to split all the people we personally know to the subsets of quiet and emotional, in many cases we are uncertain in making a deterministic decision. If you say the person X is emotional and add a degree of your confidence, it will better reflect your real knowledge. Here comes the concept of fuzzy sets. Another interesting example is a set of all tall people in a group. Set 6 foot as tall. If all are lined up and measured and 20 people are included in the set of all tall people, say, therefore 80 people are classed as not tall. But some of the people in that not tall set could be a 5 foot 11 inches. We could not say someone of that height is not tall. So fuzzy logic or fuzzy set theory says that things can be members of a set to a degree. That is, partial membership is needed here. In fuzzy set theory, a person who is at least 6 feet tall is a member of the tall set to a degree 1. The person who is 5 foot 11 inches could be a member of the tall set to a degree of 0.95. This is the difference between classical crisp set and the fuzzy set theory. Fuzzy set theory accepts things that can be partly true and partly false. And the classical crisp set theory, either the object belongs to the set or it does not belong to the set. The first one is the fuzzy set theory membership function, that is characteristic function. The second one is the fuzzy membership function. Here we can see that in all the crisp, the memberships are graded as 0 and 1, either 0 or 1. But in the case of fuzzy sets, the partial membership from 0 to 1 is allowed. These are the well-known membership functions because there is not a single fuzzy set for all the problems. Hence, there are some standard way of describing membership functions in the case of fuzzy sets. First one is the triangular membership function. Second one, trapezoidal, Gaussian, bell-shaped, S-shaped, and so many functions are there. This is the difference between fuzzy and probability. Fuzzy is not equal to probability actually. Membership function is not equal to the probability function, but both map x to a value 0 to 1. PA of x measures our knowledge or ignorance of the truth of the event that x belongs to the set A. Probability deals with uncertainty and likelihood, but membership function mu A of x measures the degree of belongingness of x to the set A, and there is no interest regarding the uncertainty behind the outcome of the event x. Event x has occurred and we are interested in only making observations regarding the degree to which x belongs to A. Therefore, fuzzy logic deals with ambiguity and vagueness. Here is an example. That is, in a bottle of water, 50% probability of being poisonous means 50% chance. So 50% water is clean and 50% water is poisonous. But 50% fuzzy membership function of poisonous means that the water has poison, and that means the water is half poisonous. Fuzzy set is represented in the name of by linguistic variables and hedges. Here are the examples. Wind is a little strong. Here, wind is a linguistic variable, little is a hedge, and strong is a linguistic value. This is the flow chart of the fuzzy logic controller. Actually, the input data are given to the fuzzification interface, and after using the knowledge and inference, we get the result. And before getting the output, that is the process, the objects are defuzzified, and then the output is given. So within this control system, fuzzy control system, from the input to the output is given in this flow chart. This is what actually the fuzzy logic controller does. Identification of variables. Input, output, and state variables must be identified of the plant. Next one, fuzzy subset configuration. So here fuzzification process is going on. Then next one is obtaining membership function. That is obtain membership function for each fuzzy subset. Then fuzzy rule-based configuration. That is we are assigning fuzzy rule base to the concerned problem. Then normalizing and scaling factors are processed, and then the fuzzification process is done after this. Then finally defuzzification. This initiate the defuzzification process to from the crisp output. Otherwise the implementation will be difficult. This video gives just the outline of what is a fuzzy set and why do we need a fuzzy set. Thank you for your patient listening.